Hello, I'm Lily, and in this video, I'm going to discuss angular displacement, angular velocity, and acceleration of the uniform circular motion. I already explained uniform circular motion, centripetal acceleration, and velocity in my previous video. Let's say our rotating body is at angular position θ1. Just I show it here. This point. That is the angle, and we know θ1, that is here, is equal 0. And at time t2, it's at angular position θ2. So I show this one. Let's say this angle is θ2. So we have θ2 and θ1, and this one is delta theta, that is equal to θ2 minus θ1. And just remember, theta should be in radian. Delta theta is angular displacement of this object. And you already learned that average angular velocity is equal displacement divided by time, or is equal s divided by delta t. So I can write it like this. So as a result, we can say average angular velocity is equal to angular displacement divided by time, or delta theta divided by delta t, that we show average angular velocity with omega. And remember, theta should be in radian. In addition, we know if our object travels 2 pi, it means it travels 1 revolution. And then it means if we want to look at the distance traveled by the object, is circumference of this circle, that is equal to 2 pi r. So if the object travels 2 pi, if delta theta is 2 pi, then s is 2 pi r. Right now I want to say, if we say the angle travel or angular displacement delta theta, then I want to show distance travel is s. And I want to find relationship between delta theta and s. As a result of this one, I can say s equal 2 pi r times delta theta divided by 2 pi. We simplify 2 pi by 2 pi, so as a result I can say s is equal to delta theta times r. So we have omega average is delta theta divided by delta t. We have v average, that is equal s divided by t, and also right now we know that s is equal delta theta times r. It means displacement for linear motion is equal angular displacement times r. So I want to use this formula to find relationship between omega and v. So I write omega is, again I write it delta theta delta t. I'm using this formula, and based on this I know delta theta is equal s divided by r. So I substitute delta theta, which is s divided by r, and just delta t stays here. Then I can say s delta t, we already learned s, and if I put delta here, s delta t is equal v average. So I can say omega actually is equal v average divided by r, or it means average linear velocity is equal average angular velocity times radius. So this is the other formula that we got. So to summarize, average linear velocity is displacement divided by time taken. Average angular velocity is angular displacement delta theta divided by time taken. The relationship between S and delta theta is S equal delta theta times R, and V average is equal omega times R. You know, linear velocity is a vector quantity. It means it has both magnitude and direction. So angular velocity is also a vector quantity. It has both magnitude and direction. For finding its magnitude, we just can use formula delta theta divided by delta t. But how we can find the direction of angular velocity? To find the direction of angular velocity, you need to curl your right hand somehow that your finger points in the direction of rotation. So as you can see in this simulation, the object rotating clockwise. So my right hand is clockwise, my four fingers pointing clockwise. And then your extended thumb will point in the direction of the angular velocity. So right now my thumb pointing in the direction of angular velocity, as in this case is into the page. Right now I change the direction of rotation of the object and find the direction of angular velocity again. This time, as you can see, the object rotating in the clockwise direction. So my four fingers should curl in the direction of rotation, that is clockwise. So it's like this. And then my thumb pointing in the direction of angular velocity, that in this case shows out of the page. So we saw that the angular velocity is a vector quantity, and right now we know how to calculate its magnitude, and using right hand rule we can find its direction. Right now we want to find out about angular acceleration. In my previous video we learned that AC, that is centripetal acceleration, is equal to V2 divided by R, and its direction always is towards the center of the circle. Right now, and also in this video, we learned that V equal omega, that is angular velocity, times R. Just in this formula, I substitute V with equal. So I write A and we show this one with alpha, and this one is angular acceleration. So angular acceleration is equal angular velocity squared times R. Another important thing that we need to remember is the farther a rotating object is from the axis of rotation, the greater is the circumference of its circle, and so the faster its linear speed must be. So as you can see, for this green bug, the circumference of the circle that it travels is larger than the circumference of the circle traveled by this red bug. But they travel together, so it means time taken for both of them is the same. But one of them at the same time travels larger distance, so it means the speed, the magnitude of speed for this green bug is larger than red one. But if you want to think about angular velocity, for one revolution, both of these bugs travel 2 pi. So their angular displacement is the same, and also we know the time of travel for both of them same. So as a result, they have same angular velocity but different linear velocity. I hope you found this video helpful and thank you for watching.